Hi. I'm John Vomar, and I live here in Northwest Arkansas. You know, it's really quite beautiful here. We also have a great university, the home of the Razorbacks. I also plan on going there after high school. I also love math. In fact, that is the very reason why I did this project. Specifically, this project's subject is none other than the classical Sieve of Eratosthenes, the deterministic method to find the list of all prime numbers up to a certain limit. Okay, now let's take a look at my project code. The first thing I do is I call in math. Then I create a class called Sieve. I use the class to define the input and make sure that value errors are raised and are called if it doesn't match my parameters right over here. I also use the class to begin defining variables and some functions. First, we define it as the sieve function and tell it that the limit is going to be an integer. Then we add 1 to the limit so that the 0 place is accounted for and set all of the integers up to the limit as true for being prime. This allows us to eliminate any calculated composite numbers. Then we set 0 and 1 to be false, and then we start the loop. It begins at 2, and then goes all the way up to the square root of the limit. No prime factor can be larger than that limit. Then it multiplies all of those primes out to create and eliminate all of the composite numbers. Since everything else is already set to true, those are the remaining prime numbers up to the limit. What is produced again is defined again at the function getPrimes. Now let me show you one of the functions that is not in the Sieve class. What we have here is the getTotalFactors function. This function retrieves the prime factorization of the input and does a few interesting things with it. It finds the number of times the prime appears and treats it as a power. It then uses the exponents up to that power and multiplies the primes until all of them are exhausted. Then, when the loop is finished, it returns a sorted list. In main, I go ahead and prompt the user for their input. Then I implement all of the functions that will be used later to print the output to their input. Also, additional input is required to keep running the program. Now let's take a look at me running the program. First, I type Python of project.py to start my program. When I hit enter, the program prompts me to enter a number. Let's say, for instance, that I choose the number 100. Hit enter, and just like that, the list of primes up to 100 appears. As an added bonus, the list of composites also appears. After that, the program first prints a few statements above the next prompt to guide the user. Then it prompts me to type in a composite number from the list above, or just type the letter O to use my original number. Let's just type in O. Hit enter, and look at that. We have the list of prime factors of 100. It then prompts me again to hit enter to see all the factors of my number, prime and composite. So I hit enter, and here we have the list, prime and composite factors of 100. Then finally, it asks me again to hit enter to see all the factor pairs of my number, which pairs of numbers multiply to it. Hit enter, and voila, we have nice, neat brackets with both numbers in each. All of these results are quite useful in solving numerous mathematical factoring problems and testing the primality of numbers. That concludes this presentation. This was Sieve, primes, composites, and their factors.